Today I'm here with Grzegorz Buczko at the Pronar factory in Poland. Let's take you around and see how a wheel is made. Poland, a country of just under 40 million people, has been experiencing rapid economic growth. By some projections, they may have recently, as of this year, 2025, surpassed Japan in GDP per capita. However, this hasn't always been the case. Once the most devastated country in Europe during the Second World War, its current revitalization only started in 1989. Once free from communist rule, a newly created Eastern European democracy was formed. Poland has been building their economy ever since. In every community, there is now a sense of pride in their country, their culture, their history, and their newfound economy, which is growing exponentially. Today, you are going to see a special part of Poland's contribution to the world. This factory produces agricultural wheels for the largest equipment makers on the planet. For the first time in history, you're going to see all of it on film. Nine production facilities, 2,500 people, and why this region?
Why this region?
Yeah.
Because the owners were born and raised in here. They were neighbors in the same village.
Yeah.
And they appreciate, local community. They wanted to support the community.
This is impressive. Got it ready.
Unrolled from the coils in our steel warehouse. They are already cut into desired dimensions. And they are going for the first machinery on the line, which is power glass machine.
So that's the width. If we go take a look at this,
Yeah,
this is going to be the width of the wheel.
that's going to be a rim.
That's going to be a rim, yeah.
Yeah, that's going to be a rim. So funny fact, from a flat sheet of steel, we are making complex shape round rim using several stages of the process. The material, it's just how it's left, the steel mill.
These will be cut in different thicknesses? You guys order them?
We are ordering them in different thicknesses, in different material grades, and we unroll them from coil. And this machine is currently feeding good providing clients, but the capacity is much more soon. And those are twin lines, they are mirror shape, but it's all the same. So we walk around this side. The flat sheets of steel are being power blasted, just to get rid of any impurities and prepare the surface already for the painting.
Okay.
So it's like sanded texture.
Sanded texture.
Yeah. And,
Just like that wheel that's hanging up there. And all these.
so from a flat sheet of steel, we are making a tube. On this rolling machine, we can make a tube from a steel which is up to 10 millimeters thick. After making a tube, we are using those two machines to weld them together. So you can see the seam line over here for the weld.
Yeah.
Along with the running plates. So in order to have a full weld across the full width of the ring, we need to get those running plates. You can see the welding happening over there. You can see that we have videos of a machine working. So each stage of production has its own quality control. Quality control for us is not at the end of the process only, when we have a finished wheel. At each stage we have our own quality control. So we need to see if the welding has a full melt across the full thickness of the material.
Yeah.
Then we are rolling the weld area in order to have a perfectly flat surface, and we are cutting out the running plates. And this is a pre-component for the rim profile.
What's the purpose of the running plates?
If you would start welding at the edge of the material, welding the core material around the weld is taking out the heat.
I see.
So at the edge, there is no material here to take the heat outside. So we will have an overburn. There will be basically a hole. We have to start the weld. We want the weld to be perfectly fine in all the width, all of the section of the cross section of the rim. So we need this running plate. We start to weld on the running plate and then move around to the material.
Okay.
Then we are cutting them out. So this is the area. As you know, also from our cooperation, it's where we are connecting the rim shells that we profile ourselves. This is
and the rim.
press piece outside. They're perfectly matching inside diameter of the ring. So we are welding only from the one side. At this stage, after we press it the disc into the rim shell, we are testing the runout. If the runout readings are are okay for us, they are according to norms, we can proceed and put it to the welding machine. After the full welding of the wheel, we also double check the runout, because during the welding process the steel is being heated up and then it shrinks when it's cooling down. It can cause a bit of a movement of the disc inside, so we need to do double check of the runout. For 90 degrees each. That's a start and stop of each welding nozzle. So one welding nozzle is only making a quarter of a turn, and we have a completely welded wheel.
I see. Quality spot welding. Okay. How do you know if this is a deep well or a well? A DW or a W?
It's basically a shape. So here you have a bead seat area.
Yeah.
And then we have two steps. That's DW.
Okay.
If it would be only a one step, and then
I see. A little hump here.
yeah, there's like an additional hump. So that's DW. Bead area is over here, and you have those two steps.
Now this is quite a process here.
Yeah, that's our paint shop. Again, this is probably most modern. That's the stop after this post.
So all these wheels are getting ready for paint.
You can see this is the incoming feeding area of the paint shop. So So there are several stages of preparation before we even apply the heated primer. So after the production process, during which we are welding, we are using machine oil, there can be a lot of impurities after the wheel. We need to prepare it perfectly fine for the paint. So there are several stages of rinsing with mineral-less water, with special chemistry, which is already giving us some initial protection against the rust. We also implemented phosphorate zinking into this process. So before the wheels are dipped in the eco tap, they are already pre-prepared. And we have eco primer process, which basically looks like we're taking the wheel and it's feeding into the big bath eco primer. In this factory we are using light eco. You can see the converter there.
Yeah? Like a primer?
Yeah, it's like a primer. And of course, after we dip it into the eco, it goes to the oven. It needs to be heated up and then cool down again. And then move the powder application. This area is the buffer area for the ring production. Size of wheels hanging. We are basically taking each core which is available to our on the market the same line. So we need to combine or divide production buttons for the painting. This is for the button area. This is the reason we kept steel button over here. So the wheels are waiting for the either the same color or similar size each. You can see already inspection of the eco primer of the wheel. Some defects from material imperfectness can be verified only after painting it, not before. It cannot be seen on the bare metal. Then there is a chamber from the button coat. In our chamber we use robotic arms. It's to be automated. The chamber can also clean itself automatically without human.
Really?
When we are changing color, it cleans itself. In this case, yellow color, and it can change to the red color.
Okay, we are in the finished warehouse, short term, getting ready for shipment. All the Skittle flavors.
You can see the same wheel from both sides. So we can see masking from top coat area. This is the hub side. There is only a top coat. There is no powder over here.
Sure.
You can see how sharp is this line, and also this under the nuts.
Now, why would somebody order wheels like this?
It helps to avoid loosening bolts in some machines.
Better, tighter fit, better torque.
Yes, correct. Tighter fit, better torque. And when the machine is working, there is a lot of vibration.
Yeah.
Sometimes the bolts are being loose. Not all of the end users are watching this, so it helps to, let's say, extend the maintenance when you need to check the torque.
And what would you call this? You call this a waffle style wheel?
No, it's an adjustable wheel. This one is going for our call it a multi-fit system.
Yeah. And the multi-fit is designed to do what?
So we are adding the disc in here, and you can change the offset, you can change the track of the machine. At the same time, you have a wheel which is not that much different from a welded wheel, which is the most durable construction at all. So it's like a heavy-duty adjustable wheel. You can see it's almost like a pearl finish in the wheel. Like you have on your car.
This is almost a metallic.
Almost the metallic or like most of the adjustable wheels we are making in the factory, old factories. We have a station where we are joining together rim with flanges, rim with lugs, along with the discs. Something extra.
Relatively unique to Pronar. So what you're saying here is that you're not putting an extra layer on where the bead is supposed to be seated.
Yes. It's only light when there was some blown of the top coat, but it's basically no top coat on this area. So it avoids tire slippage. You have a better connection between the bead seat and the nair link area. You can feel the nair link area. It's not sharp, but it's avoiding tire from a slip. And if you're not applying top coat in this area, it gives even better anti-slippage, tire slippage protection for the assembly.